Dad, what's the future gonna look like?
Thanks, Cyrus, for inviting us to present here. I found it really interesting over the last 2 days. There are so many innovative companies here. All of them, though, I would say, face the challenge of how do you really scale and scale in an economic way. Elon Musk, a couple of years ago, described his auto factories as massive furnaces for capital. And if you've ever set up a factory, you know truer words have never been spoken. And yet, we really have not fundamentally, from a first principle standpoint, looked at how you would completely change manufacturing into something that was not a massive furnace for capital. I founded Divergent about a decade ago to focus exactly on that problem. That problem, to summarize it as concisely as I can, is that you have very expensive tooling for a single product, and then you have a factory that's set up to basically create that one product. It's inflexible, it takes a lot of capital, and that's the problem you need to solve. Divergent started out as a clean sheet look at how you revolutionize manufacturing, how you do it in a way that takes a comprehensive software-driven approach to engineering and then allows you in a toolless way to manufacture whatever you generate with that software, and in a fixtureless way assemble what you then manufacture. A decade later, that technology is in place. It's been commercialized first in automotive with 6 automotive customers that we have: Aston Martin, Bugatti, Ferrari, McLaren, Mercedes, AMG, and Porsche. And today we have, for the most critical safety structures of their cars, structures out on Aston Martins, out on Porsches, and out on Ferraris. And then all 6 companies will have vehicles out on the road with parts that were generated using a machine learning-based system, fully engineered by that system, 3D printed by machines that we build in-house at a rate that's, I'd say, 10x plus from a cost productivity standpoint better than the most cutting-edge available 3D printing technology. And because we design the assembly structure into the structures themselves, we can use the same robotic cell to assemble whatever we print in one end-to-end system. And so Divergent is, in our view, the next generation end-to-end design and manufacturing company that can distribute and scale manufacturing across multiple industries. But our focus really is starting with auto and aerospace and defense. Recently, we closed a $290 million financing for our Series E. Over a decade, I've raised about $1 billion in capital. It took about $500 million to build the initial system and about another $200 million to commercialize it in automotive. Let me see. So, I was talking about focus on automotive. About 2 years ago, some of the main defense primes reached out to us. There are 3 major problems that our defense industrial base faces. One is we've completely lost our overall leadership in production. before the Civil War, America already had 40% of global manufacturing capacity. By 2000, that had fallen to 27%. China, in turn, only had 7% of global manufacturing capacity in 2000. Post WTO, that has risen to around 40%, and America has fallen towards 11%. We need to be able to, particularly for defense, obviously reindustrialize. We're working across 3 different pillars. One on legacy weapon systems with companies like Lockheed and RTX. We're redesigning existing systems, re-engineering them so that we can, at real volume, then print and scale production of those. On future weapon systems, we're working on unmanned air, land, sea, and space vehicles, some of which I'll show you in a second. And on the sustainment side, obviously there are many, many parts where casting companies that were manufacturing them no longer exist, both here in our NATO allies where we sold old equipment. We can very, very rapidly, say in 24 to 48 hours, re-engineer those, and then in any machine that we have, be able to produce those in any quantity, from 1 to thousands. So those are the 3 areas we're focused on aerospace and defense. These are 2 examples. One on the top is sustainment. So bell crank for a C-130 tail rudder. They could not find a vendor to cast that over a 3-year period of time. You know, in desperation, AFSOC, Air Force Special Operations Command, came to us. In 1 weekend, we re-engineered that, manufactured, and shipped that to them. As I said, any machine that we have, anything that gets generated on the system can be printed and assembled by the same machines. The bottom example is on a low-cost cruise missile system for one of the major primes. From the start of engineering, and usually this is a couple-year timeline to do this, we went from T0 of engineering to delivering test-ready airframe for that structure, and we're doing everything from warhead without the energetics, full missile body, wings, empennage, all generated by an AI-based system and printed and delivered within 10 weeks. So what's the advantage of doing this? This is an example that's actually been published by General Atomics that we did about 2.5 years ago on a smaller unmanned aerial system. We took that system, which had about 184 parts, re-engineered it through our machine learning-based system, and reduced that to 4 parts. So what happens is things like fuel tanks get printed in, the bracketry gets removed, fuel lines get printed in, you massively reduce the number of parts, and if you need to make any changes, literally, it's a couple hours of compute time to do it. We reduced, even though we were replacing a carbon fiber outer mold line, we reduced the mass of it. We reduced production cycle time from 12 days to about 10 hours. We reduced the development time from 18 months. Now we have it down to 10 weeks. It says 4 months there. And massively reduced variable cost and development cost. So this is actually faster, better, cheaper with a system that's design agnostic. No more expensive tooling for one product and factory for one product. You rapidly generate, using automated software, the product structure, and then on any machine, you can do any product. Within the first factory we've built in Torrance, California, we're doing about 450 different structures out of the same printers and the same assembly systems. This is what the system looks overall. It's called Divergent Adaptive Production System because it's a machine learning based system. We first software define the architecture. We input a set of requirements. We have a full digital twin of our print and assembly process. So when a structure is optimized, say the rear frame for a hypercar, we not only generate the optimized structure, we generate the optimized printing and assembly instructions. Those can immediately be sent to any of the printers we have. Those printers are manufactured by the factory itself as well. We're doing about one a week by the end of the year. This year, we'll be doing one a day by mid-year next year, building one printer a day to scale up. And then we have an assembly system that I'll show you a video of that allows you to take those printed parts, and because the structure for assembly is in the part, using the same assembly system, assemble any product off the same assembly system. And my business partner is my son, who's 31, and this is actually a photo of us with Aston Martin Vantage frames. So we are shipping frames to Aston Martin. Those are the most critical safety performance structures in the cars. Those are out on production Aston Martin Vantages today. This is a quick video. It's about a minute long that I'll take you through that shows the process. So you get the picture there. This was actually a quick shot of doing a rear frame for a Mercedes AMG vehicle. It's kind of sped up from 4 minutes to 1 minute. So I'll actually fast forward from that. So what we're doing is actually acting like a combination of design tools plus a, say, fully digital distributed Foxconn. We do that as, you know, a manufacturer, outsourced manufacturer for these companies. We're working with, I'd say, basically every single major prime and a lot of the secondary primes. We have, within 18 months, we've gotten over 30 production contracts. We're also obviously working on the auto side, so this is a dual-use technology. Like Cyrus said, we actually have our own captive hypercar company. It's called Czinger Vehicles. We're delivering 80 vehicles over the next year. We've delivered about 15 now. About a month ago, we drove one of our cars off of the assembly line. They're fully homologated, meaning they've been through full crash, full emissions, 50 state emissions. We drove it to 5 different tracks in California over 5 days, drove it over 1,000 miles, and set every single production track record against the McLaren Sennas, Ferrari F80s, basically smoked every single track record as an American performance car built within 3 years from start to finish and being delivered as a fully homologated vehicle around the world. So what's the idea? One factory, any product, from small structures all the way up to doing collaborative combat aircraft fuselages, propulsion systems, both internal combustion engines, jet engines, gas turbine jets from 150-pound to 750-pound thrust, rocket motors, rocket tubes, obviously not energetics for warheads, but the warhead itself, not the propellant, but the tube and the motor itself for rockets. As I said, everything from 20 to 30 foot long fuselages, hypersonics, satellite buses, sustainment, all done off of the same generative design software, all done off of the same printer that we've done in-house, all done off of the same assembly system that we've done in-house. And that slide somehow didn't come across completely on this, but it's supposed to be the US and Indo-PACOM. The idea now is we're going to start replicating factories. The next two are going to be near military bases in Oklahoma and in Alabama and likely Honolulu. But the real vision for this company is to provide dual use capacity and tools so that in a distributed way, people can design and manufacture without having to put up capital for a single product and put up capital for a factory. And that to us is the only way that the US is going to actually reindustrialize and become leading manufacturing power again. Thanks for listening.
The future is gonna be awesome.